Okay. So do I have the floor?
You do.
Okay. Well, first of all, I just want to say thank you so much for inviting me to be there, Jeff. And it's funny you were going through everything, and I'd forgotten half of the stuff you were mentioning. So, and that introduction, I don't know if I can live up to that, but yeah, thank you for inviting me to be there today, this morning. One of the things that I wanted to ask real quick was, does the group, and I can actually see the camera of the group here. Is anyone in the group fairly familiar with Packet, or is there a bunch of people there that don't know anything about it? I'm just trying to get an idea what kind of room I'm dealing with.
I would say that you're dealing with a room that doesn't know too much about packet radio.
Okay, well, that's kind of how I put this presentation together, assuming that. So that'll work out great. I didn't want to find out that I was talking to a bunch of advanced users and you're all rolling your eyes going like, "Yeah, dude, we know what that is." Okay, good deal. Well, I guess start off, my name is Jason Rausch. My call sign is K4APR. I was licensed originally as KE4NYV, and that was back in 1994. I was about 12 years old at the time, so I've been doing this stuff a long time. I love it. Amateur radio, obviously has been basically a lifelong hobby for me, and it even turned into a career. Um, I I worked with various Motorola radio shops for years, and then eventually I made my way to NASA. I was at NASA for 10 years, working in an RF communications lab, basically designing RF systems, mostly voice RF systems, and we were kind of a unique lab because we were the engineers, the operators, and the maintenance. So we kind of took care of everything from soup to nuts, so to speak. So I did a lot of that for 10 years. Eventually left there, went directly back and went to work for Motorola directly. I was with them for 6 years. Um, uh, when I left Motorola, I did a little bit of a switcheroo on my job or on my career. But I actually just a few weeks ago took a job as the radio system manager for there's a sister city right next to us here called Suffolk, Virginia. And I think I heard somebody asking where I was from. I meant to say that I'm in Chesapeake, Virginia. So if you look at the map of Virginia, in the very bottom right corner of the state, right up against the Atlantic Ocean, there's a cluster of cities there. We don't have counties in this part of the state. They're all independent cities. Um, You'll see Virginia Beach, Norfolk, Portsmouth, Chesapeake, and I'm in Chesapeake. But anyways, I give you an idea where I am geographically. But yeah, there's a city just west of me here called Suffolk, Virginia, and I got hired as their radio system manager. So now I maintain, or I mostly manage the entire radio system for that city. And that's been a fun job. That was actually kind of where I was kind of heading to when I was with Motorola, and just took me a little longer than I had planned on. But anyways, so just a quick little bit about me as far as amateur radio is concerned. Yeah, I love DMR, P25, the digital voice, packet, and APRS. And just full disclosure, if anyone's familiar with Tapper, the Tucson Amateur Packet Group, I'm on the board of directors for them. So Packet runs pretty deep with me. But also, if anyone's familiar with the APRS Foundation, I'm a board of director on the APRS Foundation. So both of those things are very important to me, both APRS and Packet. And of course, we're going to talk about how APRS is Packet. And we'll talk a little bit about that in the presentation. But yeah, those are the things I'm really into as far as the hobby. I love building and designing stuff. I'm always building my own gear, mostly packet related stuff, a lot of PCB design, and yeah, so that's pretty much mostly about me. Um, oh, I am married and I do have a daughter, and they both tolerate me, so I guess I'm doing all right there. So. All right, so is can you see my presentation? Is that up and showing?
Yes.
Okay, just want to make sure. All right, so let's see here. All right, so since I'm dealing with a group of folks that are not real familiar with Packet, this hopefully this won't be confusing. Hopefully this will be a good primer into what Packet is and how it works. So let's start with the basics, the fundamentals of Packet Raise. So I've got a list of things here that I'd like to discuss um, during this. So Packet is digital. Digital is ones and zeros. I think pretty much everybody understands that this day and age. Maybe 20, 30 years ago, that might not have been such a common understanding, but today I believe it is. So that helps. Packet is based on the AX25 protocol. We'll talk a little bit more about that. I'm just going to hit these bullet points and then we'll go into detail on the rest of these. Some of the more common speeds and modes for Packet is 1200 baud AFSK and 9600 GFSK. And we'll talk a little more about that again. We'll talk about as far as how the modem and the radio connect to each other and how they function together. We'll talk about a computer or a host computer of being able to connect to the equipment and be able to operate Packet. We'll talk about that. We'll talk about connected versus unconnected Packet because there is both kinds. And then we'll also talk about the TNC2 versus KISS interface. And again, as we get into this, those will make more sense. So Packet is made up of ones and zeros. It's digital. Um, those ones and zeros represented by where we're called mark and space tones, and those mark and space tones are alternating depending on if it's sending a zero or a one. And of course, we're talking at the bit level here, so we're talking about sending zeros and ones directly. I put an example of 1200 and 2200 hertz. These two tones make up the mark and space tones for 1200 baud packet, which um, uh, is the most common or most regularly used packet speed. Again, we'll talk about that a little bit more. I put a little diagram here, not to confuse, but to just kind of show how the tone. So I think we all understand that 1200 hertz versus 2200 hertz, the frequency, the higher the frequency, the shorter the wavelength, or the shorter the period of the tone. So you can see in this diagram where the ones. I should specify, and I really should switch this in this slide. 1200 hertz is represented um uh by ones, and 2200 hertz is represented by zeros. So if you look in this little diagram, you can see where the wavelength is wider, where the ones are over it, and you can see where the wavelength is shorter, where the zeros are over it. And that's exactly how this works. So as they're sending ones and zeros, the wavelength changes. It changes, or I should say the frequency changes, the 1200 hertz, 2200 hertz, and it just alternates back and forth. And as you can see, they're just showing the example of sending a string of 1 0 0 1 0 1 1, and you can see how the wavelength or the frequency is changing for each 0 or 1. Okay. So let's talk about TNCs versus modems, and if you've ever heard of Packet or did anything with it, you've probably heard commonly TNC, but you may not have heard the word modem as much. Now, we all are familiar with the word modem because of our computers and the internet and all that stuff. So that word's not foreign, but when it comes to packet radio, it really is two separate things. So first off, the TNC, or what is called the terminal node controller, it is a modem, but it's a modem with a lot of extra features and functionality that is included in it. So it can do a lot of different things. So I just put some examples like being able to perform connected packet or act as a BBS mailbox. And there's a lot of other functions that a typical off-the-shelf commercial TNC can do. Also, one of the things about TNC is that the interfaces, and we're going to talk about this a little bit later, is that the TNC will take more of a just a raw data, and it will format the packet based on that data that you gave it. So that's another thing where it comes versus a modem versus a TNC is you're just feeding kind of raw data to it, and then the TNC itself is formatting that packet for you. Whereas a modem is simply a device that can take the data in, and it's got to be in a specific format. In this case, KISS is pretty typical, and we're going to talk about KISS. So any of these terms I'm using, just kind of tuck them back for a second because we're going to eventually hit these in some other slides. But basically, the modem is there to key the radio, modulate the transmitter with those tones that we talked about, and an external computer is required to structure the packet. So those are the two big things I want you to understand about this. The TNC can take basically a raw feed of data, and it formats that packet internally in the TNC before it sends it to the radio. Whereas with a modem, or just a flat out just KISS modem, all that formatting needs to be done on the computer side, and then it's fed in a formatted way to the modem, and then the modem just its whole purpose in life is just transmit this data over the radio and let the other end deal with the deconstruction of the packet. So the AX25 protocol, which we mentioned earlier, it's a specific format, data structure format for the data that is being sent in the packet. Now, these are the four main um, elements of an AX25 packet. You have the address, the control, the PID, and the payload. Okay, so just real quickly, the address contains the call sign of who sent the packet and who the packet is meant for. Okay. So there's going to essentially be two call signs in that address that's encoded in there. The control identifies what kind of packet is being sent. And we're going to later talk about connected and unconnected, and that's really where this is indicates that. It indicates to the receiver, is this a packet that's meant to be connected or unconnected? The PID, or the protocol identifier, is used to tell the receiver what kind of packet is this. And this isn't the connected unconnected thing, but what kind of format is this in? And in this case, we use AX25 in amateur radio, so the PID basically never changes, at least for us. The payload is what is really the most important, and that's what data are you actually sending? What is this packet being sent for? What is the information in the packet? And that's what goes in the payload. The This is just a continuation. The address field is kind of important because it is what indicates who sent the packet and who is meant for. Okay. Now, don't get confused by this table, but I do like this because it does break it down. And this is I included this as more as an understanding. You don't necessarily have to know this to get into packet. You really don't. If you were writing software to do packet, you would need to understand this. But this is something I wanted to just kind of show. So if you look in that first line, you see it says byte A1, A2, A3, and so forth. Those are corresponding bytes. If you look in the very next row down, it says ASCII. Now, we probably see something kind of familiar there, don't we? That's a call sign, NJ7P. And what is done is each letter of the call sign and the letter and number of the call sign is split up over these six spaces. And those individual characters will be encoded in binary, which is the third line down. And then it can be converted to hex as well. But I want to jump back up to the second line real quick and just point something out. If a call sign is less than 6 characters, we can't just send it like that. We have to pad out those extra spaces with actual spaces. So a 1x2 call sign a 2x1 call sign like we have here in the example doesn't meet the full 6. So that's why a space is there. And they actually encode that space, that ASCII space to, and the reason they do this is that the packet, the address header has to be a specific length, and it can't be any shorter or longer than that specific length is specified in the AX25 protocol documentation. And that's why you have to pad these spaces out. Now, again, the software that you're using is going to do all this automatically in the background, but I just wanted to point this out because this is something that's important when it comes to packet. The sending station has to send it a specific way because the receiving end is expecting to see it the exact same way. The receiving end knows that that needs to be 6 characters. So the transmitting station has to send it that way. So that way there's no mismatch, no mismatch of length or data or anything like that. And the last thing I wanted to point out is if you've done packet or APRS, you might be familiar with the term SSID. The SSID, for those who don't know, is a way of using your same call sign up to 16 times. You can have your call sign by itself. You can have your call sign -1, -2, -3, all the way up to -15. And that's what allows you to be able to use your call sign multiple times. And that's what that SSID is. And it's encoded in a certain way. And I even mentioned here that the SSID is encoded in binary, but it's a different method beyond the scope of this presentation. I could tell you about how all that works, but I don't want to confuse you and I don't want to bore you either. All right, so this is a little better explanation of how a TNC versus a modem would handle this data. So the a TNC or a TNC2, most TNCs have the flexibility of acting as a controller with a simple terminal. And what that means is if I want to send a message to Jeff and I just want to say hello, when I'm connected with a terminal or a computer running a terminal program, as long as he and I have established a connection, all I have to do is type hello, enter. That hello text is going to go into the TNC. The TNC is going to say, okay, this hello is my payload, like we talked about a couple of slides ago about the payload. And it's going to take that and it's going to format the entire packet internally in the TNC. And then it's going to send it out and transmit it over the radio. Okay. Versus KISS, which is the protocol that is used. It's a simplified protocol between the computer and the TNC or the modem. But in this case, we're really talking about the modem because we talked about the modem before being a very simple device. It doesn't have a whole lot of intelligence other than it knows how to take a KISS formatted string and transmit it over the radio. So that's what's happening here. So if you look at this diagram, you can see in the red down below, that might look familiar to you because we just talked about that a couple slides ago. There's your address, control pin, and your payload. Okay. That is the meat and potatoes of our packet. If you look in just above it where it says KISS to the left there, this is a KISS packet. And what this is there's a flag at each end. This is C0 flag. What that does is that indicates everything between these two flags is going to be packet data. This is the data that I need you to send. So what they do is they take that AX25 data or that AX25 frame and they put it in that data frame in between those flags and this command byte. And now you have a KISS packet that is ready to be sent over the radio. This whole thing is sent to the modem. And instead of the modem trying to translate it or figure out what to do with it, it just knows that it needs to send this over the radio just as is. Okay. And it's going to send it just like that. I'm sorry, I got my words twisted up here. The command byte is simply just telling the modem what channel to send it on. And when I say that, KISS modems can have internal channels, channel 0, channel 1, channel 2. Typically, channel 0 is what's used unless you've got some kind of multi-port modem. In this case, we're not talking about that. We're just talking about a single port modem, single radio. So that command byte would just typically be the same throughout. And just like a couple slides ago, I talked about how, or I gave you that example of hello got sent to the TNC, and the TNC formatted. In this case, the KISS format packet is being sent to the modem. All that formatting was done on the computer end. All that was done before it ever got to the modem. Now the modem just takes that data and sends it out over the radio. That's it. So you can see where the complication is either in the TNC or the complication is in the software in the computer. So it's one of those two are going to take care of creating that packet. It just depends on, do you want do you want the software to do it, or do you want the modem or the TNC to do it? So as far as interfacing a TNC to a radio, it's a pretty simple. You're gonna have a transmit audio, receive audio, push to talk, and ground. And that's simply four wires that go between the modem or the TNC and the radio. Radios are going to vary as far as how you interface to them. I used the V71 as an example here. The V71 has a 6-pin mini DIN port on the back. This is commonly referred to as the packet port. A lot of radios have these now. More modern radios, the Yaesu, a lot of Kenwoods, even some ICOMs have them. But that port has kind of become the industry standard. And the idea behind it is that if you have a modem or a TNC that already has that port and the radio already has it, there's no soldering or any cable building involved. You can take a mini DIN to mini DIN cable and it's plug and play. And this has actually been something that I heavily weighed on with my company. All the devices I make, whether they're APRS or modems or whatever, I put the mini DIN port on because I want to make it as plug and play as possible for the end user. Same thing with radios. I've got a lot of different adapters I've made for various radios. Being a Motorola guy or a former Motorola guy, I use a lot of Motorola radios, commercial radios for packet and voice. I use it for both. But for example, if anyone's familiar with Motorola mobile radios, the older generation, a lot of them had a 16-pin port on the back that was perfect for interfacing for a TNC or whatever you need to interface to. And I've got an adapter I designed that plugs on the back of that and converts it to a mini DIN. And that makes it a lot easier, more plug and play. So if you're looking at getting into this stuff, those are things that I would recommend. Look for radios with either they already have the mini DIN port or potentially a radio that could have one added to it. I'll tell you a really good 2-meter radio is the old Kenwood 271, which was a 50-watt 2-meter mobile. It was a monoband mobile. That radio actually has the pads inside to add a mini DIN port. It's like a pigtail coming out of the back. And I always tell people, if you're in the packet and you see a 271, pick that thing up because they're great for packet. And it's real easy to convert. Okay, so let's talk about connected and unconnected packets. So we mentioned this earlier. So connected is a session-based connection between two stations. A connect command is issued by either one of the stations. The TNCs, once the receiving end hears that connect request over the air, they will handshake and they will establish a connection between the two of them. So at this point, both TNCs are kind of married to each other over the air, and they will stay connected until the connection remains until one of the stations terminates it, and that can be done one of many ways. But basically, it establishes this connection, and then we mentioned chatting. I mentioned an example about typing hello. So I'll use Jeff again as an example. So Jeff and I, let's say that we are both running full TNCs that are able to do connected packet. I do a connect space Jeff's call sign. Jeff, I apologize. I can't remember your call sign off the top of my head right now.
N5XHI.
There you go. All right. So I do connect space N5NXI. And my TNC will send a packet over the air saying, hey, N5NXI, I want to connect to you. His TNC hears me. It goes, yep, that's me. And it sends a packet back saying, let's establish a connection. And at that point, the TNCs they might chatter back and forth one or two packets just to establish that. And now we're connected. And let's see, let me jump back real quick, So this Cantronix KPC3 that you see in this picture, this is probably one of the most common, most popular TNCs ever made. Still made today. You'll see that there's a series of LEDs on the front. You'll see one that says con. That's what that is. When we are physically or when we are connected over the air, our TNCs will both light that con or connect LED to indicate that we're both connected to each other. Okay. All right. Let me jump back here. Okay. So that, and then at that point, we're established connection. And then all I have to do is I can type whatever I want and hit enter. And that will send that as a packet over the air, and it will just display right on Jeff's display. And then he can do the same thing, and we can chat back and forth all day long like that until we disconnect. Okay. Um, so that's connected. That's a good example of connected. Unconnected is often referred to as a UI frame. Uh, no two stations will connect to each other using this, okay? Rather, each station is monitoring the frequency for packet data, and the packet data is essentially meant for anyone who receives it, okay? Um, I said you transmit in the blind, but that's not really true. You're transmitting in the blind, not knowing if anyone out there is actually hearing you or listening for you. But transmit in the blind can be misconstrued as I'm just transmitting, not knowing if anyone is there. I don't know if anyone's there listening, but if somebody else is transmitting, my TNC will detect that and it will keep me from transmitting over top that other person. Okay. So, so I want to qualify that because that gets people twisted sometimes when they see that and they're like, well, that's illegal. You can't transmit over somebody without me. And that is true. But like I said, the TNCs, they actually have a function in there called DCD or data carrier detect. And what that's going to do is it's listening all the time on the radio. If it hears another packet, it's going to detect that and it's going to temporarily keep me from transmitting. Even if I already hit enter and told the TNC to transmit, the TNC will buffer that and it will wait till the channel is clear before it transmits. Okay. And the most common use of unconnected would be an APRS. So if anyone, I'm just curious, is anyone in the room APRS users?
Again. Is anyone APRS user? Yes, that's a no.
Okay, all right, okay. So in APRS, APRS is more of a, and again, I'm very careful with this word, more of a broadcast type thing where you're transmitting your position as you drive along, or just transmitting some kind of APRS data, not knowing if anyone can hear you or anyone is gonna hear you. Um, that's really how APRS functions. You're not directly connecting to any specific other station. All right, so this is another interesting topic, especially today. Most people would just think of a computer today, whereas years ago we could have had just terminals, and it wasn't necessarily a computer. It was just basically a screen and a keyboard, and there was some intelligence in it that was able to talk serial data to some kind of mainframe or some kind of other thing that had more intelligence than it had. Okay. Um, Today, computer and terminal are kind of synonymous. Computer is capable of running specific software, such as an APRS client that can format those KISS packets that we were talking about. It does all the heavy lifting for the modem. Versus a terminal, um, it can be a specific device, like we mentioned. It can be an actual terminal device, or it can be, and it relies on the TNC to do the formatting. So that's going back to that slide where I typed hello and the TNC formatted all the packet data before it sent it to the radio. Okay. Um, that's where a terminal would work with that, but I would not be able to use a terminal, so to speak, with a regular modem because the terminal doesn't know how to format that data correctly. Um, Now a terminal these days would likely be a terminal emulation software that's running on a computer. So if anyone's familiar with the client Putty, Putty's a terminal client. Um, there's TerraTerm, and of course now it's slipping my mind. It used to be included with Windows. It's not anymore, unfortunately, but there was a terminal program that used to be included with Windows. Of course, the name is slipping my mind right now, but that's all software that was written to emulate what a terminal device used to do. When you used to have this separate device on your desk acting as a terminal, it wasn't a full blown computer, it was just a terminal. These days, it's emulated in the software. So that's the difference between those. So let's talk about some practical uses for packets. So we already mentioned APRS, and I mentioned it's unconnected. WinLink is another one. I'm guessing some folks in the room might recognize WinLink. WinLink's kind of interesting. It uses a KISS modem, like we talked about. So all the packet formatting is done in the WinLink software, but it is session based, meaning that it's using the modem to obviously be your transport over the radio, but the WinLink software actually creates a WinLink session. So when WinLink initiates that, it will connect to, for example, a WinLink RMS node that you might have in your area. It will establish that connection with it, but it's doing it internally in the software. That's where the connection. So the modem is not going to have a connect LED on the front that lights. Even if you're using a KPC3 in KISS mode, which you can, that connection LED is not going to light. That connection is being established in the WinLink software. There's a node-based packet network such as TARPN, the Terrestrial Amateur Radio Packet Network, which is something that I'm heavily involved with in my area. And then there's a keyboard to keyboard chat that we mentioned before, that example I used with Jeff and I, connecting with our TNCs and just doing a chat back and forth over keyboard. And I should have specified that when we're doing that, we would be using one of those terminal emulation software packages like Putty or TerraTerm or anything that can simulate or emulate a terminal. That's what we would be using. So nothing special software wise, just a terminal application. Okay. So APRS, since it sounds like no one in the room has really done any APRS, I threw this slide in. This is a client called Yak, yet another APRS client. What's unique about Yak is it's written in Java, so it will run on pretty much everything. It'll run on Windows, it'll run on Mac. I'm running it on Raspberry Pi and Linux. That's what this screenshot here is from a Raspberry Pi 4 that I have running over here that's doing nothing but the APRS, and it's running Yak. But APRS is a really unique application for Packet. So one of the things I always try to make apparent is that APRS is not its own digital protocol. What it is, it's a certain formatting of data that is fed into an AX25 packet. So APRS is packet. It's just the data that's being sent in that payload. So it's formatted in a specific way, but it's in that payload. So it's still AX25 packet. There's nothing different there. It's just the data that's being sent. But APRS is a lot of fun. If you're looking to get into something, in Packet, this is a lot of fun to play with. One of the things that a lot of people don't realize is that APRS, so it was developed by a gentleman named Bob Bernenga, WB4APR. He's passed away sadly, and I knew Bob. He was a great guy. He had a brilliant mind. He was always coming up with new stuff. But anyways, one of the things he realized in the late 80s, early 90s, well, I guess it really was their early 90s, is that a packet was falling out of favor. A lot of people were just not really doing it anymore. And a lot of the packet gear, people just put on the shelf, they just weren't really using it anymore. And he was like, I got to find a way to reuse this stuff. So he started developing APRS because he knew all this packet gear was sitting out there idle on a shelf collecting dust. And that's really was one of the revivals of packet in a certain way and the reuse of this equipment. So APRS had a lot to do with that. And we're now seeing kind of a packet and APRS renaissance now. We're seeing an explosion in packet. Um, if you're on Facebook, obviously there's the North Texas Packet Group. That's actually the group that Jeff, encouraged me to join, and I saw what they're doing there. But uh, the packet itself is making a resurgence, and it's really great to see because it's honestly it's what got me in the hobby. I saw a demo of this when I was a kid, and I just thought this is great. I really want to do this. This is what and now we're seeing a resurgence of it. So that's really great. Um, I mentioned tarpon. I was going to put a little more information about that here, just because again I'm pretty heavily involved with tarpon. Tarpon's a good example of a structured packet radio network. It's a node-based network where each member of the network actually has a node at their house. And I include some pictures. These are some node boxes that we've been building. Um, uh, Not too complicated. Um, but we will get together periodically and build half a dozen of these together or more, depending. But the point of having the node at each home or each person's location, it's a better use of the bandwidth and the load sharing of the data. Um, in the old days of Packet, there would be one single node, and then people would concurrently connect to it. And they quickly found that once you had about 3 or 4 concurrent connections, the bandwidth went just into the mud, and it wasn't very effective. By doing it this way, we have discrete frequencies assigned to each link, and there's only 2 users on that link. It's node A and node B, and then node B and node C. But node C and A will never talk directly to each other. They'll talk through node B. And those links are dedicated between those 2 nodes, and it can load share. So if A is really busy for a second, then node B can just hold off until node A is ready, and then it sends the packet. Nice thing too is no one's stuck to one speed. Like let's say there's the single node that I gave the example of, and it just operates at 1200 baud. You're stuck at that. Everyone's got to run at that. But if you have all these individual links, each link can run what they can handle. So if me and one other guy are 2 miles from each other and we've got a real solid connection, we can run 9600 baud without an issue. But between him and the next guy might be like 7 miles, and they're just finding that 9600's just not, it's those packets are getting mangled. So maybe they drop down to 4800 or 1200 or whatever is ideal for that particular link condition. And I already mentioned this, it's point-to-point links between, but this is a great project too. This is another one of those projects I encourage. If you've got a group of people that are interested in doing packet together, this is a great project to do, because it really brings you together as a group. You kind of have to plan it out. You get to build all this stuff together. If you don't know much about packet or anything, I say tarpon's one of the best ways to learn stuff, because um, you'll learn about packet, you'll learn about wiring, you'll learn about soldering, you'll learn about Linux, because each one of these is run by Raspberry Pi. So there's not a full-blown computer anymore. There's just Raspberry Pi, based on your argument, is is a computer. But a single Raspberry Pi in each one of these node boxes at like $60 is way better than a $400 laptop or something. So, anyways, you can learn a whole bunch of really great skills by doing a project like this. And if anyone's interested in tarpon, feel free to reach out to me. I'd be more than happy to, give you more information and kind of lead you in the right direction to get started because this is a really fun project. In my area, we've got about 35 of us that are currently working on it. Now, only about 12 of them are on the air right now, but that's because, everyone's at a different stage of getting an antenna up or, or doing this or that so you can get their node on the air. But we're slowly growing. All right, and that's pretty much all I had. Are there any questions that I can answer?
Have a list.
I have one. What are the typical baud rates that are used these days? When I was involved in packet, 1200 was very prevalent, but are they going faster now?
Yeah, so 1200, like I mentioned, with APRS is kind of the de facto standard still with APRS. However, like the Tarpon network I just mentioned, we always start the link at 1200 just to establish it and make sure it works, And then at that point we try to go up. Now, one of the things, let me click back a couple slides here. So the this TNC right here is called the Nino TNC, and if anyone's heard of the Nino TNC, you know what a bargain it is. So there's a through hole kit version of it, and then there's this surface mount version. Now the difference between the two is about $15-$20. You can buy all the parts and build your kit for 45-50 bucks. You can buy this pre-built and it just works for 70, basically. Those are basically your price points. Now, the reason I'm bringing this up, this TNC can do 1200, 2400, 3600, 4800, 9600, and 192. So 19,200 baud. Those are all baud rates. Okay. It also has IL2P, which is something that's new, which is being adopted, which is forward error correction, which is something that Packet never had before. Packet had what's called CRC, which is a error check, okay? But the problem with that is that if the CRC didn't match, meaning that there was an error, it just threw the packet out. It didn't do anything with it. It just threw it out. And hopefully the sending station would send it again. Okay. I2LP or IL2P is a forward error correction where if it gets a packet that doesn't meet CRC, it will try to repair it. It'll try to fix it and try to figure out what's wrong with the packet, and you can recover a lot of packets that way. So, anyways, I bring that up because this TNC is the very first device that actually supported that. There's some software TNCs out there that Dire Wolf and some that are starting to employ that as well. So it's becoming a thing. Now, this TNC, even if you bought the surface mount prepaid or pre-built version for $70, can do all of those speeds. The KPC 96 or the KPC 3 that I showed, let's see, where is that? This. Back in the 90s, this was $150 brand new. And I know because I got one for Christmas and I still have it to this day. It's one of my prized possessions. Today, that same TNC is almost $250. Now, they've made some improvements. They've added USB and some other stuff, but essentially that's a $250 TNC. Now, it can do connected and a lot of these other functions, but that's all it does. It only does 1200 baud. There's a model of this called the KPC 9612 that's made by the same company. It is capable of 1200 and 9600. Okay. But it's about $450. The price goes up significantly. Whereas this TNC right here can do those speeds and so many more. Now it can't do connected. It can't do all those other special features. But if you just need a modem to handle the packet and you're doing something like Tarpon or APRS or anything, this is all you need. And now you've got way more speeds. Now, as far as the speeds are concerned, there is something that I need to point out. 1200 baud versus 9600 baud. There's some big challenges there. So 1200, I can connect that to just about any radio and make it work by ear. I can just kind of tune it and it works. When you go to 9600 baud, you run into an issue where you can't interface that through like the mic and speaker jacks of an HT, or even just through like the microphone jack and the external speaker jack of a mobile. The reason is that packet is not really audio anymore. If you listen to 1200 baud packet, you can hear the tones alternating. If you listen to 9600, it sounds like static. And the reason it sounds like static is that there's no longer tones being used. It's directly modulating the transmitter. Okay. So it's literally just keying it off and on really fast. And that's where you get that static. You can't do that through, let's say I have a 9600 baud packet being received over a 2 meter mobile, and I take that audio out of the speaker jack, okay, the external speaker jack on the back. I'll hear the audio, okay, or I'll hear that static, but the TNC will not be able to decode it. And the reason is that it went through some audio filters before it got to that speaker jack, okay? Those audio filters in the radio mingle and beat that packet up to the point where it will never be decoded that way. So what you have to do is you have to either modify the radio or get a radio that has what's called discriminator output, and that is receive audio before it hits all those filters. It's typically something you'd have to go in and find that spot on the PCB and pick that audio off before it goes through those filters, okay? Same thing with the transmit side. You can't transmit through the microphone jack because there's filters and other things that are being done to that audio that mangles it. And by the time it gets to the transmitter, even though it will go out over the air, it won't be decoded. You can't decode it on the other end, okay? And I'm bringing that up because the Nino TNC, for example, can do 1200, 2400, and 3600 baud. Now, what we have found is those three baud rates can operate just like 1200 can. You can interface them to a radio, basically the simplest way through the mic jack or in the external speaker, and those baud rates will work without modification. Once you get to 4800 baud and higher, that's when you need a radio that is capable of doing that discriminator audio and direct modulation to the radio. There's a lot of commercial radios out there that you can do that without modification. There's a couple we use. There's the Motorola CDM 1250 series, as well as the Tate. If anyone's ever heard Tate, their data radios are great for that too. No modification whatsoever. You just connect to it and it works. So that's why I brought that up, because this TNC is so, I'm sorry, modem. This modem is so capable that it's really hard to justify buying a KPC3 or 9612 unless you really need that connected packet mode. If you don't, if you're just running APRS, if you're just doing BPQ node like Tarpon uses, then all you need is just a regular modem like this, and you can do it, for way less. I know there's a little long-winded on that answer, but hopefully that answers what you were asking.
Hey, Jason, I got another question.
Sure.
If I want a mailbox, is the only way that I go for packet is a hardwire TNC?
Well, that's the easiest way to do it, just simply because it's built into the TNC and you kind of control it right from there. The other option is there is some software out there, and it's escaping my mind right now. Somebody wrote a software that will allow you to use a KISS TNC like the Nino TNC, so you can use it cheaper. And they have a mailbox function built into the software, whereas somebody can connect to your station and they can leave you a message that way. I'll research that and see if I can figure out what that software was. I don't know if it's still being maintained, and that's why I'm reluctant to say, yeah, go do that. We find a lot of times in Packet, people will take on projects and write software, and then they'll lose interest, and then it just kind of falls into the to the cobwebs of the room. So I'll see if I can figure that out, and I'll send you a message with that.
The reason why I asked that is because I have two RMF nodes that I like to use the frequency for packet also, and have an alternative frequency for packet if somebody wants to come into the node packet. And I didn't,
right.
The old way you'd use this a KPC3 or PK96 or one of
Yep.
those.
Yep.
So I
Yeah.
just wondered if there's another option for me.
Gotcha. Gotcha. Yeah, I think your only real option is like I said, I think there's that software. I'd have to research and figure out what that software was called now. I don't think it's WinTNC. There's a software out there now that actually recently got a big overhaul. It's called WinTNC. WinTNC is actually interesting because it will allow you to use a KISS modem like the Nino TNC. And as long as somebody is either running a full-blown TNC or they're running WinTNC at their end, you can actually establish a connected packet link between you, just like you would in the example I used with Jeff earlier about, we both have two TNCs and we connect to each other. WinTNC is capable of doing that, but it manages the connection from the software side, not the TNC side, because it's not a TNC, it's a modem, but it knows how to format those KISS packets that the modem understands, and it maintains that connection on the computer side. Um, Another example, we talked about WinLink very briefly. WinLink will do that as well. You mentioned an RMS node. We have a couple of those here. I'm actually getting ready to put one up myself that actually runs dual 1200 baud and 9600 baud with two radios and two Nino TNCs. Um, and I'm actually going to run them dual baud rate. So the 1200, or I'm sorry, the VHF link is going to be 1200 baud, and the UHF link is going to be 9600 baud. So I'm going to actually serve both of those as in my RMS node, so that way I can do a little bit faster packet with it than just 1200 baud. But WinLink's another option for that as well. It requires a little bit more, infrastructure to get it, going. But WinLink will do that as well.
Because when I set up the post office for the WinLink, it takes over everything.
Yes.
And I would like to have it where my post office, I can use post office, or I can use VARA, or I can use AX25 through the sound modem also.
Right. And our local Chesapeake club here, they actually are running they're running both VARA as well as they added the TNC option. So people like me who prefer to use packet, I can connect to it with packet, versus if somebody wants to connect to it with VARA, they can do that. They've got it set up to support both. Um, but I agree with you. It's just nice to have that flexibility for your users, Well, like
Right.
VARA, one of my big beefs with VARA is that it's a software modem, which is fine, but you have to run it on Windows. There's just no other option. Um, that's why I'm such a proponent of packet, even for WinLink, because you can take one of these modems and run packet all day long, and you can connect it to wherever you want. If you want to run it on my phone, I've got it's I forget the name of it now, but on Android there's a WinLink application on my phone.
Well,
Wode, yes, thank you, Wode. Wode, I run that, and I take one of those Neo TNCs like you see in the picture there, and I connect it right to my phone, and I run WinLink over packet right from my phone or my tablet, either one. And because it's got a USB interface and Android supports USB, I can do that right from my phone or my tablet. I can't do that with VARA, And the VARA guys refuse to open up the protocol. In fact, one of my friends up in Canada who writes a lot of the firmware for our products, he and I, we tried to talk to them about would they open up the protocol so we could make a hardware modem for VARA, and they refused. So they're stuck until they're willing to open that up
Well,
or
my
some.
understanding, WinLink does have the source code for it, but their agreement is they cannot use the source code until something happens to the developer.
Oh, okay. That's a new one on me. I hadn't heard that yet. But
So in other words, we won't see anything until something happens to his
which
stuff.
is
He put in the
sad.
bucket.
It's sad. Yeah. Yeah. Were there any other questions that I could answer?
I've got a question about the mini DIN connections. Can
Yeah.
you explain a little bit how there's two different receive audios, the 1200 and the.
Yeah, absolutely. Tell you what, give me a second. I'm gonna pull up a diagram of that, and that will be probably a lot easier to explain if I do that.
I've actually
my head around how they, or why they can't be combined.
Because of those, we talked about earlier about the different audio paths. Um, because those audio paths are different, that's why there's two. Now, there are Kenwood, for example, what they do is that on some of their transceivers, so you always have to go in and tell the radio if you're using 1200 9600. It's a menu option. Turns out on some of their radios, the 9600 baud pin changes, so you can actually use that same pin for both. Um, let's see here. Let me drag this over here. So funny enough, one of the first pictures that popped up was one of my pictures. That's this diagram on the far right side here. Yeah, I actually wrote it in German. So this is a standard pinout for a packet port on pretty much all radios that have the mini DIN packet port. So you have a squelch. This is the one thing we didn't talk about in the interface. There is a squelch option where what the radio will do is the moment squelch breaks, um, it'll send an active high, I believe, to tell the TNC. But most of the TNCs are very good at capturing the packet audio. And also, we always recommend run open squelch. Don't run squelch because the squelch gate may not be fast enough and you'll clip the beginning of the packet and you'll never decode it. So you're better off just running open squelch. And actually, the 1200 baud pin and the 9600 baud pin on here both typically are open squelch automatically. So no matter whether you're using squelch or not, these will typically be open squelch. Well, that's not necessarily true for the 1200 baud pin. I actually have found a few radios that when you have squelch set, the 1200 baud pin is actually squelched as well. But the question was about 96 and 1200. So there are two separate pins. 1200 is essentially what we call filtered audio. That's the audio that went through that filter. 9600 would be unfiltered or discriminator audio. And it comes directly from that discriminator output from the radio itself. So that is your those are the difference between those two pins. I typically just run the 9600 baud pin for everything. That way I don't have to switch anything up. Now, funny enough, when I searched mini DIN packet port, several pictures of my own stuff popped up here, including this. But actually, this right here is a product that we make, and this is that Motorola adapter I mentioned. This right here, the multi-pin that plugs into the radio, the back of the radio, and then it gives you the mini DIN port out, so it's plug and play. Now you'll notice these jumpers. That squelch pin can either be unjumpered or jumpered, and then it's hard to see, but this pin, there's actually three pins. And that's what actually selects if you're connected to the 1200 baud pin or the 9600 baud pin on that port. Okay. So that's what actually switches it back and forth. But it's, yeah, that happened to pop up. This is another example. This is another product that we make. If you're familiar with the TYT, the 9000 mobiles, on the back of that mobile, there's normally a sticker right on the back here where this heatsink is cut out. If you pull that sticker off, there's a hole there. And this is a little adapter we make that will bolt in place of that sticker. And that adds a packet port to the TYT mobile.
Jason, that little device, works great on the Anytone 588. And
oh, really? Okay.
Yes,
I wasn't aware of that.
radio.
Yeah,
And
here's an internal picture of our adapter wired, and there's actually a header in this radio So we actually, if you buy it with the harness, we include the harness, and then it's basically plug and play. But yeah, that's just an example. But yeah, the here's one that's not in German. So you can see the pinout here. Now, this is actually the male side, so actually don't get confused. This is a actually let me click on this one. This is the same pinout as the one I showed you before. So you can see where they specifically put discriminator with the data out 9600. And that Ken, I mentioned in Kenwood where you have to change the menu, tell it's 1200, 9600. That's more important for the data in pin because that's where it will route the audio, whether it goes directly to the to directly modulate or to go through that filtering. I don't know why they didn't do that on the receive side because they can obviously route that audio internally for transmit. Why would they do it for receive? But either way, that's a better explanation as to why they have them split up like that. Um, oh, so some of the KPC3s, for example, that we're talking about. Well, there's a 9612 that we were talking about. They have a DB9 on the back of the TNC. So that's the more older traditional way of interfacing to the TNC. But like I said, a lot of stuff's moving towards the mini DIN. The mini DIN's kind of becoming the standard now. Here's an example of a FTM 3100. Now they have the 10 pin on the back here. You actually have to break it out. But that's just another example of there are manufacturers that are starting to um, do that, adding the port so it makes it plug and play. Okay, any more questions?
One more for you.
Okay.
On your website, you showed a controller that you made that would replace the dip switches. Or I found a single circuit.
Oh yes. So on the Nino TNC, these first four dip switches is what controls what mode the TNC is in. Okay. So it determines if it's 1200 baud or 9600 baud I2LP. Yeah, it's a binary. Now, you can go look those up if you want in a table, and that's fine. One of the things I've got two projects with that. One was I started adding a 16 position hex rotary switch because what I want to do is I want to get away from the whole, hey, I need to be on 2400, blah, blah, blah. Okay, that's up, down, I think. You're trying to remember the switches. I want to get to the point where we're assigning these modes a number or a letter. So you can say like, hey, I need 2400 baud I2LP. Oh, that's mode C or that's mode 7. And you just go to that, and there's no guessing. But I wanted to take it a step further and let me see. I can pull this up really quick. Oh, gotta go to my other channel here.
I saw your YouTube video.
But I did a little video. There's a little controller I started designing, and of course I'm using Chat GPT because I'm not a coder. I'm a hardware guy. But I'm using Chat GPT to help me write the code. But here it is. This is a little controller. Oh, sorry.
Newest fleet.
Yeah, it's the stupid ads here.
Some people are made different. The tinkerers, solderers, the builders.
There we go.
Of this. Hi, in this video, I want to show a quick demo of this digital control panel that I've been designing for the Nino TNC. If you've used the Nino TNC before, you know that.
Can you hear the audio, by the way?
Yes.
Okay, just want to make sure.
That traditionally you set dip switches to set the mode. And unless you have those memorized or you have some kind of quick reference guide, it can be a little bit of a pain to remember which is which. So what this little device does is it allows you to select the mode using the little OLED display. and it will output the binary combination to the TNC to set that mode. So the interface is very simple. Basically, you just click in and you'll get a little select up in the top right, and then you rotate through and you select the mode that you want. In this case, maybe I want just standard 1200 baud AFSK. And when I click in, as you can see, the LEDs, I've got some LEDs hooked to the outputs just so I can show that the outputs are working. But you can see that the LED pattern matches what is shown on the top right there. The screen gives you the mode name, which in this case, it's mode 0 through mode E. F is reserved. It gives you the binary representation. And of course, it gives you the actual name of the baud rate and the name of the mode itself. So let me just pick something different here. I'll go check. Let's see. We'll pick. Yeah, here we go. We'll pick. Was that mode B? When I select it, you can see the LEDs change, and you can see they match. It might be a little hard to tell, but the top LED is the least significant bit, and then of course all the way down to the most significant bit. But you can see that it matches the number on the screen. So.
Yeah, so that's something I've been working on that I want to eventually incorporate into my version of the TNC. So I didn't want this to be an advertisement or you know or a sales pitch, but the surface mount Nino TNC, the one shown right here, that's actually my design. So I worked with Nino with his permission, and I asked for permission to relay out that entire board, but in surface mount. So that was my project. I worked on that for a couple of years actually to make sure it was perfect. So that right there, I'm working on a version of that that will still have the LEDs, obviously, to indicate transmit, receive, all that stuff. But I'm going to do away with those dip switches, and I'm going to instead include the what you just saw in the video, and it'll be more of a polished device with a case and everything. And you'll be able to just simply select the mode you want right from the front, and carry on with whatever you're doing. So. Does that help with the question you had?
Yeah, that's actually kind of what I was picturing when I stumbled on that video. That's the case. No messing with tip switches out of the right.
Yeah. Yeah. In fact, give me a second. Let's see here. I'm gonna unshare my screen here. So that project stemmed from this, which is so if you can see, I know the light's kind of bad in here, but so this right here, this is a 3D printed case. This is my another version of the TNC that I designed that has pins that you can plug into in place of the rotary encoder, or there is a front mount rotary encoder that I designed, or that I designed this for, but I like to offset it. So I know it's really, really hard to see in this picture or in the video here, but there is a rotary encoder that I added to the front. Maybe I do it like that. And that allows you to select the mode. And so that's where this original idea came from, because I wanted to make this really a a polished Nino TNC that you could select the mode without having to open it up. There you can see that mini DIN port on the back, and then this particular version uses USB-C. The next generation of this is including that controller, and so instead of having just this blank space, there'll be a rotary encoder, but there will be that OLED display on there, which will show you the mode that you have selected. So anyways, that's kind of that's from, the basic modem to this, to eventually I'm going to have that version with the OLED display on the front. So that's the direction I'm moving in anyways. Any other questions? Um, yeah, I was just wondering, I was just looking to see if I had, So there's a 9612 we were talking about. That's a KPC 9612. You can still buy these. They're just very pricey. I think the last time I looked, it was like $440 or $30 or something like that. Really expensive. Great TNCs, don't get me wrong. I mean, and then here's a KPC3 like we were looking at in that picture. This is actually the slightly older non-plus version. Um, but yeah, these are great. I mean, if you want to do the connected packet thing, I mean, you can find those used. And then somebody else mentioned the PK88 AEA Time Wave. They've been out of business for years, but a lot of their TNCs are still floating out there. There's also MFJ. MFJ made the famous 1270s and 1270Bs. I just warn you, or I'll caution you, if you look at buying one of those, make sure you have a way to test it, or somebody can prove to you it works. They had a lot of problems with those when the caps started going bad in them years later. They just started getting really, really flaky. I had a whole stack of MFJs that I gave away. I just didn't need them anymore. I just didn't want to mess with them. But there's always options. And then, like I said, look up WinTNC, that software that does allow you to use a cheaper KISS TNC to be able to do some connected packet stuff. If you don't want to mess with the connected packet stuff, get yourself a KISS TNC and play around with APRS, because that's packet, and that's there's a lot to be learned there if you want to mess with that stuff. But I'm always open. Feel free to message me, email me. I'm always willing to try to answer questions or point you in the right direction. If you're on Facebook, there's a bunch of great packet groups on there. If you're on Discord, the Tarpon, the Virginia Tarpon Discord group, we're typically all Virginians on there, but we have people that don't live in Virginia on there that just drop in and ask us questions because they're interested in starting a Tarpon network in their area, wherever they live. So it's really great to see that. I love when people come in there and start to ask us questions like, how do we get started doing this? Because I want nothing more than to spread the love of this stuff and get people doing it. There's no secrets here. We want to share that information and get people doing it. So, any last questions? I know I kind of ran my mouth here a long time, and I don't know what our timing is like here, but
Yeah, I have one additional question. So the modems, or the TNCs you have, those are Camtronics, correct?
yes, sir.
So that company is still actively in business 40 years later.
Yes, they are. They're still moving, and they still answer the phone. I call up there periodically, ask them questions about stuff, and they answer the phone every
I
time.
had a TNC one, so
Yeah, I've
they
got
go
one
back
around here
way.
somewhere. Somebody gave me one. Yeah, yeah. The TNC2 was really where things really took off because they added so many new features to the TNC, and that was originally Tapper, which I mentioned earlier. They were the ones that kind of springboarded that. And the TNC2 is really when Packet really caught on, and people were like, oh, okay, this is a pretty cool thing. Um, like I said, that was back in 93, 94 when I saw that demo with a KPC3, believe it or not. That's what they were using for the hardware back then too. And I asked for one for like that following Christmas after I got my license, and I got one, and I still have it. It still works. Um, Good gear. So if you find used Cantronics stuff, usually it's working, unless somebody really did something bad to it.
Also, he does offer a device for the old TNCs from 25 pin to USB-C. So
Oh, yes. Yeah, that's our so a lot of those older TNCs had DB25 serial connectors on them. So actually for myself, I did this for myself because I needed an easier way than instead of having to break out a whole bunch of gender benders and everything. So I designed this real simple DB25 to USB adapter. It goes to USB-C. And so I built a couple for myself, and I showed a few people, and they're like, "Oh man, you're like you should start making those as a product too." So I did. I started making these, And we sell these, but yeah, it's great for those older TNCs with the DB25. You know, you don't have to jerk around with a bunch of adapters and everything. Just plug this in. And in fact, my demo at Hamfest sometimes is I'll plug one of these into a KPC3, go USB-C to USB-C to my tablet, and I'll use one of the terminal applications that you can get for Android. And I'll sit there and show them how I do packet, or I'll camp it out on like 144.39, which is the APRS frequency. And they'll just sit there and just log APRS packets all day long on my tablet. And people find that pretty cool. Because
Have you made a 3D printer? Have you made a 3D printer case for that one?
Yes, I did. Yes, I did. I don't have a picture handy of that right now, but yeah, if anyone buys one, I'll gladly email them the STL files for it. Or I've had a few people, message me and say, "Hey, if I pay you another, $10, will you just print me a case?" And, of course I will. But yeah, we do have a 3D printed case for that as well. Uh, any other questions? I've enjoyed this.
Jason, thank you very much. We really appreciate it.
Yeah, no, thank you. Thank you for having me.
Great talk. Glad you joined us.
Thanks for having me.
And thank you for everything.
Thank you very much.
We're just gonna go back to drinking coffee and stuff. You're welcome to join us.
Okay. Well, I'm gonna jump. It's almost lunchtime here, and I'm fat, so I've got to eat.
All right.
My wife made some chocolate chip cookies for everybody here.
All right. Are my cookies in the mail?
I don't know.
All right. Everybody have a great rest of your Saturday. Take care.
Thanks, Jason. Nice to
All
meet
right.
you.
Take care. Bye.
Bye-bye.
Hey, Rebecca.
Hey, Rebecca.
Hey,
Well,
y'all.
we're hoping
Can you
you'll
hear me?
be here because you're from Virginia, where he's from.
I know. Not too far from him, probably.
Yeah.
So I guess this started at 9, huh? I guess I miscalculated. But it was recorded, right?
Yes.
Okay.
Yeah, it's recorded. Well, matter of fact, I'm gonna go ahead and stop the recording now. Unless you wanted to add something to it.
I did not.